The following training session is aimed at explaining how Reactec's R-Link system can be used to help prevent accidents in the workplace from employees coming into close proximity of moving vehicles or machinery. Within Reactec, we have a very strong belief that by measuring workplace risks, you're in a better position to manage those risks. We call it, the terminology we use for this is prevention engineering. Now, when it comes to risks created by the proximity of pedestrians to moving vehicles or equipment, we believe that it equally applies that by understanding how frequently this happens, where these sort of risks may come about, then you're in a better place to plan and create a safer work environment for people to be in and around that equipment. So that is the data of the proximity of workers to the equipment is your enabler to be able to find safer ways for people to work. Accidents and even fatalities from pedestrians coming into close proximity to either moving vehicles or machinery is a serious problem within many workplaces. Within construction, it's considered one of the top fatal injuries. Amongst forklift use, there are now approximately 1,300 accidents per day within the UK. And within rail, it is considered one of the worst fatalities for the workers who are working close to trackside type environments. Overall, it's one of the highest reported injuries, as well as there also being a high number of fatalities, either struck by moving vehicles or moving machinery. So what are your legal obligations and what should you consider as good practice? From the health and safety executive perspective, the regulations state that you are required to ensure that workplaces are organised in a manner that vehicles and pedestrians can move around each other safely. A fairly simple statement, but obviously one that carries a lot of ambiguity in just how to make that possible. It does require careful planning and effective controls to ensure that people and people working around mobile plant and vehicles, and also those that operate those plant and vehicles are aware of each other and therefore can keep adequate, safe working areas. So again, from a Reactec perspective, this is where we believe the data that's generated by the R-Link system is particularly powerful in being able to highlight where these incidents are happening, so that again, you can put in preventative measures to ensure that it's minimized as much as possible. So what are the key components of the Reactec system when used for detecting proximity to dangerous vehicles? So first of all, for the pedestrian, there's an R-Link watch. The R-Link watch is something that's given to each individual and is electronically assigned to them on a daily basis using an RFID card. Secondly, there's the R-Link beacon. This is what's required to be positioned on the moving vehicle or equipment. It uses ultra-wideband technology. It also has GPS integrated within the device, and it basically sets up an exclusion radius around itself to detect pedestrian watches which come into that range of that radius. Other enabling parts of the system, there's a charging station and two-bay gateway. These are responsible, first of all, the charging station for charge managing the watches, and then the gateway is responsible for gathering all the data from the watches and transmitting that automatically to the Reactec analytics using a range of mobile technologies, and also has available Wi-Fi as an alternative where there are mobile network dead spots. And lastly, there's the ID card, which is used to assign the watches to individuals each day. An RFID read writer is used to do that allocation to the individuals to set them up. But those can equally be a card that already exists within your company. But again, the same process is used to assign them to an individual for our system, and then it can be used in an ongoing daily basis. So how it works on a day-to-day basis. So first of all, the pedestrians, the employees would collect their R-link. So they unclip the module part of the watch from the charging station. They use the card to assign the watch to themselves. And then they clip the module into a wrist strap, a silicone wrist strap, which allows them to wear the watch snugly on the wrist. Then they go about their normal work. If they find themselves at times within the exclusion zone of a beacon, then they will be alerted to the fact that that has happened, and the watch will collect data of the when and the where and for how long that event happened in terms of the pedestrian being within the exclusion zone of the beacon. At the end of the working day, the R-link is returned back to the charging station, and the gateway, which should have been positioned within 30 meters of the charging station, will collect the data and then transmit the data automatically to the Reactec analytics. And within probably about 15 minutes of that watch being returned to the charging station, the data will be available to be viewed and for you then to start proactively working on what is that informing you of in terms of how you could improve the work environment at your site. So again, just to emphasize the key elements of the system. So first of all, there's the R-link beacon, which is the device that creates an exclusion zone around the plant or machinery. It uses ultra-wideband technology to achieve this, but basically the detection range of that particular beacon is something that you can configure between 2 and 10 meters. So completely adaptable to the type of equipment that you're looking to protect. The device can be hardwired into the vehicle if it's permanently owned vehicle or equipment, or it can equally be used in a battery-powered configuration, which has a battery life of about 100 hours. You do need to think about the nature of the vehicle in terms of the type of zone that you want to require, but a couple of the following slides will hopefully make that clear in terms of what your considerations need to be. From the pedestrian point of view in the R-link watch, it will give warnings in real time when they are within the detection radius of the beacon. The alerts are of a nature where there's a vibration, a buzzing noise, but also the screen will also alert the individual. Because the watches are personalized to individuals, then there is also scope for configuring individual access permissions or individual rights in terms of proximity to particular plants and vehicles. This is more detailed work that we will cover in another session. Included in that is the fact that you may well be a banksman and therefore are required to be closed, or you're walking a protected walkway. All of these things, we have added feature sets that allow you to enable these types of features. From an analytics point of view, the sort of data that we're collecting, I'll go into this in a little bit more detail within this session, but basically you're recording, if you like, near-miss trends, because every one of these detections, which doesn't result in an accident, is information that allows you to prevent future accidents. Because of the GPS technology within the beacons, you will have the ability to look at hotspots in terms of where the events are happening in a most frequent manner, and also be able to prioritize which pieces of plant or machinery are the cause of most of the events. So to start to talk about the beacon positioning, so the beacon itself is setting up a fixed radius, which you can configure and control both in an initial setup and then also in the field. The employee is alerted when they are too close to the beacon, but also the watch is collecting information on how long that detection took part for. And that allows us to then create red, amber, green type reports, which are aligned to the length of proximity to the vehicle, which we see as a relationship to how risky that proximity was. The other thing to consider is that you should look at the vehicle and try to imagine the radius that's being created by the beacon. And where necessary, you may well need to use more than one beacon to ensure that you collect the radius area that you're looking for. Something as simple as a forklift, a single beacon will be adequate. But for larger vehicles, you would consider more than one beacon. The beacon R symbol that's shown on the front of it will flash, as an LED behind that will flash, which is a sort of local indication of the fact that a detection has occurred. Again, just to try and clarify again what a beacon is doing in terms of its detection radius, you need to, if you like, imagine almost a three-dimensional sphere that's created around, which is centered on the beacon itself. So it has a radius, but obviously when it then hits the ground, that's the end of detection, and so on. You should try to position the beacon to make sure you cover the area of exclusion that you want. Please also be mindful of moving parts in vehicles. For instance, we do feel it's good practice to put a beacon on the boom of an excavator, because essentially the danger moves with that boom of the vehicle. Also, consideration needs to be given in terms of placement of the beacon to ensure that the beacon is not going to impact on any normal use, i.e. it's not going to get into the way of normal working, but also that itself may not be damaged during what is normal operation for that beacon or for that piece of plant. And the final piece of consideration, it is quite important to put the beacon in an elevated position. Generally, we would advise for it to be above head height, and that way it's unlikely to be blocked in terms of where it's trying to create its detection radii. But as the beacon moves in height, then the amount of distance that's covered in terms of ground area will reduce. So it's a function of trigonometry, if you like. But if you take a beacon with a radius of 10 meters and you place it at a height of 3 meters, then the detection distance at the ground is 9.5 meters. And we've shown here in a little table just how that alters with height. So in all of these figures, it's a 10-meter beacon at different heights. So at 9 meters, the ground radii is only 4.4 meters, while at 3 meters, the ground radius is 9.5 meters. All of this should be considered, given that a lot of perhaps the more dangerous vehicles that are in normal work can have quite extensive ranges of movement. So for you to be considering the diagram here, we're showing a 21-ton excavator. What we would recommend is that you have a beacon at the rear of the vehicle. Generally, that would be at a position about 3 meters on the guardrail. So it will give a nice extended radius of 9.5 meters around the ground. At a very high elevation of the boom or the bucket, so for instance, if it's 9 meters off the ground, now consideration that, you know, a tall person maybe 2 meters, but at 9 meters, it's significantly above people, but you will probably still want a good detection radius. And what that will mean is that anyone within 4 meters at a ground level will still be detected by that beacon and receive a warning that they should not be underneath the boom. Moving on now to explain a little better the role of the Reactec analytics with R-Link in preventing workplace accidents from proximity to moving vehicles or equipment. So first of all, the Reactec analytics has been designed in a manner to easily share data between multi-levels of stakeholders. It's readily accessible online, but equally well, people can gain access to the data with a range of automated either reports at a regular cadence or automated emails in response to alert events such as dangerous proximity. Within the reports, there's granular detail on the unsafe behaviour. It's all about the who and the what in terms of the equipment and where it happened and for how long there was that proximity to the danger. The information is presented in a manner we believe to help you prioritise your efforts to look at how controls can better design safer work environments, whether that's by looking at the most regular offenders or the most regular cause of the danger from the pieces of plant. And we also have within the software the ability to add your measures that you take in response to the data, whether that's a control measure for long-term effectiveness or just individual interventions at particular data events. Overall, the software is designed very much around the requirements of GDPR. It's intended to be easy for users to understand, and it's completely robust and reliable and readily scaled as your organisation grows. So looking at specifically some of the information that's available for proximity to between pedestrians and plant. First of all, please note that the whole system is very broad in its application. It was first developed for Reactec's vibration data, but has subsequently been expanded to also cover information about noise exposure and dust exposure, and all of this is available on a single platform. There's a top-level dashboard when it comes to the proximity detections. So first of all, you can look at how often events are happening, and again, in terms of the severity, whether they be short, moderate, or sustained, so the amount of time that people are within proximity to the beacons. And you can look at trends over time in terms of the average daily incursions per individual and and a leaf table is available to show by project where the most events are happening to again focus the attention where it's most needed. Other type of data that's available, so from an individual point of view, as mentioned before, we have included a red, amber, green analysis of the data. So what we're analysing here, and this is configured at a company level, you choose which amount of time you might consider as short and therefore not of major concern, perhaps because someone's received the warning and they've done as required and moved away. You might put that at perhaps 5 or 10 seconds. You might look at something where maybe 1 or 2 minutes you consider as very dangerous, and you would call that your sustained proximity detections, and moderate is everything in between. And so again, you can very quickly see from the reports where you need to focus your attention in terms of individuals who are exhibiting the most dangerous behaviour. And then you can drill into, with that individual, by date and by beacon, where these events are happening. It's also this sort of information that you can add interventions, and the intervention can be electronically signed by the individual. When we look at it the other way around, from a beacon perspective, we have reports such as a heat map, where it will summarise where the events are taking place and also show you the real hotspots or pinch points where the proximity is happening in your environment. And this is all working on the basis of the GPS location information, which is in the beacon. So this tells you the location of the beacon when the pedestrian came in close proximity to them. And you can readily filter that by individual beacons or individual people. And as has been mentioned, the real power of this software is when you take the data and put in place some actions as a consequence of what you can see within the data, actions which hopefully mean that you are preventing any future occurrences of the sort of information that you're being presented with, and as a consequence, creating a safer work environment for your workforce. So that's the end of this training session. Further information can be obtained from Reactec. We hope that you find the system is of use, but as I say, any further questions, please contact Reactec and you will find a lot of support within our website. Thank you very much.